Podcast. I'm live. Hi, everybody. Thank you for joining me today. I'm really excited to be a part of Data Science Innovators 2022. My name is Mike Grove. I am founder at Stardog. I'm our SVP of Engineering. I sit on the advisory board of the School of Information Sciences. I've spent the last 20 years of my career in the graph and AI space, particularly focusing in semantic technology and knowledge graphs, which is what I'm here today to talk about. Stardog is a leading vendor in the knowledge graph space, and I'm really excited to bring some of our thoughts and experiences around knowledge graphs to everyone here at this audience. Also would like to include a demo. Time permitting, I would love to get to some questions, so I'm going to go ahead and just jump right into things. The Bermuda Triangle is a stretch of the Atlantic Ocean, the 3 points of which are made up of the cities Miami, San Juan, and of course Bermuda. You've probably heard about the Bermuda Triangle. It's gained quite a reputation as being a dangerous place to go. If you go in, you'll never come out alive. It's impossible to navigate. It's not safe. If you're like me and you live on the East Coast and you've been to the Caribbean, you've actually successfully navigated the Bermuda Triangle yourself. It's no more dangerous than any other open stretch of ocean. And all the reputation it's gained, all the stories about it being dangerous are just in fact that, stories. What's not a story is the enterprise Bermuda Triangle. It's a dark section of the enterprise data landscape that is very difficult to navigate, and organizations are being held back by these challenges. Its points are made up of three core data management functions: storage, analytics, and governance. Enterprises need to be able to successfully and safely navigate between these to make it to their data-driven destinations. And again, this is where knowledge graphs come in. They can help enterprises find their way through this challenging stretch of territory within their data management landscape. But before we talk about how that happens, what knowledge graphs are, and what role they have to play in a modern data-driven enterprise, I think it's helpful if we just step back for 1 second and talk about some of the underlying challenges and trends that organizations are facing that has led us to knowledge graphs. Where to start? Where are organizations trying to go? Well, they're trying to get to paradise. What's paradise for these organizations? Very simply, it's putting data in the hands of the right person at the right time. Importantly, so they can make the right decision. And I know that sounds simple and obvious, just making the right decision, but the impact of those right decisions is tremendous. And this is something that organizations understand very acutely. They see everywhere they look, blogs, analyst publications, reports, they all report on the same basic trend. Organizations that use their data effectively have better outcomes. This isn't surprising. I know we've all heard this before. What's a better outcome? Well, they're businesses, so making money, saving money perhaps. That grounds out in a lot of different operational use cases covering the entire gamut of what enterprises do. But at the core of it, everything comes down to this single key point. You want to succeed in today's environment as an enterprise. Data is a big part of how that happens. You have to use data to be successful. You have to use data to stay successful and be competitive moving forward. Organizations are trying everything under the sun, every resource they have available to leverage their data and take advantage of this situation. So I think a good question is, how's that been going? Organizations have more data than they know what to do with. Tons of data professionals, many of whom are here today, that are really smart and able to use that data to do interesting and useful things to help the organization. So surely it's been going really, really well. As it turns out, sometimes you'd say there's some devils in the details. I'll stick with the theme. There's some krakens in the ocean. It's a lot harder to get to that data-driven paradise than simply having some data and then using it. There's a lot more to it. So organizations, what's happening is they're facing this headwind. And that headwind's blowing them off course, and they're not able to reach that destination. They're not able to effectively leverage data because of the challenges that they're facing. And these challenges are quite significant. When you start digging into the numbers, the companies who get there still have those eye-popping results, huge benefits to the organization. But for the most part, organizations aren't being successful. From what I imagine is the pool of all enterprises, everyone's trying to more effectively leverage data. Two-thirds of them aren't getting there. They're not making it. That's a significant amount of enterprises that are trying to understand the value and then aren't quite getting there. So what's happening? What's causing that two-thirds of enterprises, despite all their best intents and intentions, to fail to launch, to not be able to get to that data-driven destination? It doesn't take long where a lot of those complaints ground in what me coming from an engineering background, I would call tech debt. Organizations are struggling with operational kind of data management tech debt. The way we have operated our data management ecosystem isn't going to work. And it's this legacy that's weighing us down. And this is why tech debt, I think, is a great metaphor. What do you have to do? You have to pay off debt, or it'll kind of drag you under. And I think a lot of organizations, this is where they're at right now. That debt is really weighing them down, and they're not able to make the progress that they would like. So operational challenges, legacy technology, what specifically does that mean? Let's go one level deeper before we start getting to how we solve these problems. We come to a usual suspect. Data silos are not a new suspect or culprit in this story. Data silos in and of themselves aren't necessarily problematic. They're not evil. Operationally, they actually may be a pretty good choice. But silos shouldn't preclude you from using the information they contain within the wider data landscape. And that's where we start getting into the challenges. And we should have seen it coming from the name, silo, isolated. The disconnection that's created from those silos is really the root of the problem. Why is disconnection bad? Well, I mean, for a reason that's great for this audience. As data citizens, data professionals, we're trying to answer a question. It's a scientific inquiry. We don't know where that line of inquiry is going to land. We're going to have follow-up questions. So to be hemmed in and contained by a silo, or get to the edge and not have, I didn't answer my question, or what I have doesn't answer my next question. It can't let me continue my inquiry. This is why, one of many reasons why the disconnection is bad. There are two other macro trends that are taking place at the same time that is further complicating this picture, both of which, again, we've heard a lot about. The growth of data. Our consolidation efforts are lagging behind. Arguably, they may have failed. We're certainly not going to catch up. We're creating and generating more data than we can keep up with. And that's compounded by the fact that copy and paste is currently an enterprise function. So we're exacerbating the data growth problem and the silo problem. That's where we're putting all that new data and one-off silos. And now we have this very disconnected system, and it's growing ever more disconnected and growing ever larger. The other trend that makes this even harder is the rise of cloud and multi-cloud. Today, as a data professional, my data that is relevant for me, for my use case, it's all over the organization. It uses every technology available. It moves at every speed. It's a very hard problem. Tomorrow, I have the same problem, except my data is spread across the entire internet and all of the clouds and all of the places data could be stored across the entire globe. That is a true challenge. This is why it's hard to do something with data. You're fighting against this state of play that you can't succeed. So how do we start turning this around? How do we start getting a system that allows enterprises to move past this legacy tech debt, to leave it all behind and start really embracing some of these data-centric principles, being truly data-driven? So now let's kind of pivot back to where we started. and talk about the enterprise Bermuda Triangle. To recap the 3 points of the triangle: analytics, storage, governance. Core data management functions. These are the things our organizations are doing today. Arguably, organizations may be very good at each of these things. We make data lakes, we make warehouses, we create ever bigger piles of data, and are very excited about the possibilities that entails. We create sophisticated governance processes to talk about all that data. We create multiple catalogs. There's always multiple. There's never just a catalog to talk about that data that we have in storage. And certainly we're doing lots of analytics. So all of these things are happening in spades in organizations. So what's the problem? The problem is they happen entirely in isolation. When they don't happen in isolation, the integration between them is ad hoc and it's not reused. So what do we see? We see very familiar outcomes. We spend a significant amount of time and money creating a data lake or data warehouse that ultimately doesn't drive the insights that we're after. People look at that data and have difficulty understanding what it means or struggle with data quality challenges because all the information about the data and what it means, that's all locked away in a separate system, kind of in that governance layer. So what happens? The horror stories about data scientists spending none of their time doing data science, and instead fighting against the grain here and trying to beat data into shape and do these ad hoc integrations. This is not a very scalable strategy to have these practitioners, these very good professionals, have to do turn share activities, to literally have to move from one system to the next to be able to integrate and put something together. And then ultimately that effort's usually thrown away and it's not available for the next person to take advantage of. So they don't have to do the same turn share activities. So we want to create something that is cohesive and brings all these things together. And as I foreshadowed earlier, this is where knowledge graphs come into play. What's happening is these core data management functions, storage, analytics, and governance, as I said, we act on them as if they are in isolation, but in fact, they are all connected. And this is the root challenge. They are siloed in a sense, kind of at that macro level. So what do we have then? We have a data integration problem. We need to integrate the data from these 3 core parts of the data management world together into a single cohesive unit. That's how we start changing the game and really unlocking the value that we can get from data. And knowledge graphs are all about data integration. This is what they do. They do it at enterprise scale. So they're a really good fit. They're based around graph, which is a really natural way to think about and talk about data. And we'll get into some of the key pieces here, but this is why I think ultimately everything comes together within knowledge graphs, because it gives the organization the ability to put together these 3 things and use them as one. And that gives organizations the capability to successfully navigate through that Bermuda Triangle and find that destination that you're trying to reach. How do knowledge graphs do this? What are the 3 main capabilities that we're looking for in a knowledge graph platform that make all of this work, and in particular, make it work at enterprise scale? The first and one of the more important ones is virtualization. Have to accept the modern world. Data lives all over. It's internal to organizations, it's external to organizations. It's all across the internet, moving at every speed. We have to embrace that. That is the world that we live in. So we need our technology from a very fundamental level to understand that and to respect it. Now, the trick with virtualization is that spans every technology. Like for likes aren't all that alike. SQL systems, Postgres and MySQL, 2 good systems. PostSQL, fairly different to work with. Same thing could be said of Mongo, Cassandra, and the NoSQL world. And obviously, SQL and NoSQL are quite different. So then Graph comes together being the crux of this virtualization layer. Graph is the natural data model. It's how we think about data. If you've ever gone to a whiteboard, you probably drew a graph. So it gives us this very natural way for us who have to deal with the data to think about it. And it also gives us an easy way to connect all these different pieces. So we start collecting and connecting all these different data silos. This is the first step to breaking down the walls between those silos, this virtualization layer. Once you've collected all that data into that large virtualized graph, it's time to add the semantic layer on. And what the semantic layer does is overlays that data in place with precise business meaning. So we're encoding what that data means unambiguously. And this is the key. That meaning, it lives with the data. It's not separate, not in the catalog, it's not somewhere else. It's with the data. It's where it should be. This way, we can leverage it alongside the data. So you take these two capabilities and you put them together. We have data in place, spreading everything that the organization could care about with very precise business meaning that's relevant to my organization. This is great. We have an asset that we can continue to build on. This puts all of the pieces of the puzzle all in one place. So now we can start assembling the picture. And the inference engine, the final capability here, is one of the ways that you do that. So the inference engine takes that semantic layer to kind of the next step. Whereas the semantic layer, if you've done any EA modeling, business level modeling, a lot of the mechanisms are going to feel familiar there. It's kind of same with the inference layer. Simple if-then style rules to codify concepts in your world. One of the cool things about this is now we've got dynamically applied business logic that scales our enterprise and spans silos all across the internet. That's pretty cool. As an engineer, I find that very exciting. But the really cool thing about this is that you can have multiple kind of semantic layers or multiple lenses, we like to think of them, that let you interpret the data. And I think this is really key for a knowledge graph because it prevents you from getting boxed in. Something we learned from MDM. There's no singular truth. There's no right answer to what a customer is or is not. No two groups in the organization necessarily have to agree. So your knowledge graph can actually support multiple different potentially contradictory views of the world. Sales and marketing can say, Mike Grove, he's a great customer because we can sell him a lot of things. Finance may look at me and say, well, Mike's more of a consternation. He's a cost center. It costs money to not lose his data. Not a very good customer. Or they don't even think of me as a customer. They just think of me as a cost center. So to support these different ways of slicing and dicing the data is absolutely critical, but you have to be able to do it without moving or changing the data. And that's really key. And that's why you could go build this yourself, but this is why it's part of the platform to be able to do it at scale across the entire enterprise. So these three kind of key pillars are wrapped around what's ultimately a very simple process. So you can kind of see them here in the middle. You're taking your data silos of your organization, you're applying kind of these three principles, you're creating a knowledge graph, and that gets bubbled up for all of your data science, data citizens to be able to take advantage of that information. This is meant to happen iteratively. This is meant to work in 2-week chunks. You can take one source, move it through, you can virtualize it, link it into your knowledge graph, enrich it, precisely codify that meaning, build an inference data model on top to allow a particular view of that data, and then publish it out and make it available for everyone in the organization to consume. This is very different from your traditional data lake or data warehouse, any kind of big scale operational stuff where it's a multi-person, multi-month, multi-dollar operation. This can be done by a person in an afternoon. It can be done by a team in a couple of weeks. You can very quickly and efficiently build up a knowledge graph using investments the organization's already made. And soon you'll get it to take advantage of the network effect of having brought all that data together, broken down the walls of those silos, and created something that's truly transformational for your company. If we jump to kind of a architecture view of all of this, you can see it's kind of the process flipped on its side. On the bottom, we see the data silos, but chief amongst them, we're calling out the data catalogs. That's an important part of that storage layer. And a good example of how storage and governance bleed together. They're not separate things, they are connected, and Knowledge Graph brings those together. We see that virtualization layer yielding our kind of virtualized knowledge graph, data modeling, that's that semantic layer, the inference engine that we talked about. And then included here, machine learning, graph analytics, statistical ways for inferring new information. We think those should be part of the compute layer because all of that data ultimately should be part of the knowledge graph. You shouldn't have to have reverse ETL or other complex operational mechanisms to take what you've learned and put it back into the knowledge graph or put it back anywhere to let other people use it. This is just how knowledge graphs operate. That's why it's included here in this compute layer. But at the top, access. This is where the organization gets this data, how they access and talk to the knowledge graph. This is very boring. It supports everything the organization already does. So SQL, GraphQL, Tableau, Power BI, Jupyter, R, REST, Java, JavaScript, Python, all the stuff your organization already uses, all of it already works with the knowledge graph. This isn't new technology. This isn't start over. It's not rip and replace. This is something that's purely additive to everything the organization already has. Just another reason this is transformational technology, because you can transform your one source at a time. A couple quick things I'd like to get to before diving into a brief demo. There's a lot of folks here. I suspect many of you are coming from the healthcare world. You may be familiar with principles of FAIR data: findable, accessible, interchangeable, and reusable. Really good principles to keep in mind when you're thinking about how to create like a data management ecosystem to support the data efforts of your enterprise. All data should be fair. Knowledge graphs are kind of fair by their very nature. And the really cool thing about this, as this study from McKinsey shows, and there's others like this, organizations that share data have better outcomes from using that data than just simply if that data was available and not shared, kind of hard to find. So it's a really nice thing where taking this approach, adopting knowledge graphs, will help organizations more effectively use their data, but it also comes with some kind of for free features such as widespread data sharing. Within reason, knowledge graphs are tapped into enterprise security, so you're not going to share anything that shouldn't be shared. But to make that data more widely available makes it easier for others to leverage and re-leverage those investments. Now we've got about 10 minutes left. I'm going to jump over and do a quick demo, but I do want to just kind of recap what we talked about before we do that. The enterprise Bermuda triangle, it sits between core data management pillars, storage, analytics, and governance. These to date have been operated as if they are silos in and of themselves, and the disconnection that silos create, both at the micro level of a single data silo and at the macro level of things like analytics or storage or governance in our organization, that disconnection prevents us from being able to use that data in the way we want to be able to use it. Knowledge graphs are all about data integration at enterprise scale. And this is why they're the future of data management, because they're going to break down the walls of these silos on the macro and the micro scale and provide a capability and a platform to let the data citizens in our companies finally start getting everything out of data and get to that data-driven destination that we had in mind. So with that, I'm going to go ahead and jump over to a demo so everyone can see knowledge graphs. There's a new audience, so I think a lot of people maybe haven't been exposed to a knowledge graph before. So I'm here in Stardog Cloud, and I'm just going to jump into a couple examples. The first one of which is a healthcare data set, and I can go ahead and just search for something quickly. I can see a variety of things that I have that I've been attached to, but I can be more specific because I have precise meaning and can find exactly what I'm looking for in this data set. I can jump right to it in the knowledge graph. I can see here information about where this data came from. So that's kind of tapping into the data sources. We'll get more of the catalog integration in a second. But I'm a doctor, and maybe I'm interested in risperidone, so I want to go ahead and isolate this in the knowledge graph and then open it up. And you'll see a gray node pop up here that corresponds to a connected component. So there's people information here, and I do what you do with people data. I ran social network analysis on here, and I was trying to find networks of doctors that came together. And the interesting thing for me was that these two drugs ended up in this component. So with a little bit of digging, I realized these two drugs bind or target the same protein. Doctors probably know this, but for me, this was new and it was easy for me to find. And this is the point. It was easy for me to find because it was just part of the knowledge graph. I didn't have to do anything special. That graph analytics funneled right back into the knowledge graph. Let me show another quick example of that for an insurance use case, trying to predict or suggest premiums for customers. So a particular customer, Bob Stiles, he lives in a lovely house here on Gerard Street. That's everything we know about Bob. And we can go in here and see this quote for $4,087. This was created using a similarity model that was put together from this knowledge graph. And again, the results from that modeling go right back into the knowledge graph as soon as that model is trained, so I'm able to leverage it. I don't need to do anything in particular. I don't need new skills. I don't need new tools. That statistically inferred data is just a part of the knowledge graph. I'm going to jump over to a customer 360 use case. Oh, I should jump to the right database though. All right, customer 360. So what I want to do here is I want to find customers meeting particular criteria. So I have a form, and this is driven off of that semantic layer. So I know what properties customers have. And, maybe my use case is sending out thank yous or some sort of token of appreciation to these folks. So I want to go and find customers matching specific criteria. Maybe in this case, big spenders. Big spenders probably bought things in the electronics department. That's where a lot of our big ticket items are. So I want to go ahead and search for anyone who's made purchases in the electronics department. And I go ahead and run this query. I'll see 100 customers and many, many more that was trimmed off. And I'm just now realizing I forgot to correctly set the data I was using. You see it won't change in this instance, so it's still that same 100. I want to refine my search. It's synthetic data, so you have to excuse the kind of outrageous price here, but I want to find customers who have bought more than $20,000 worth of merchandise, and I want to reward our loyal rewards customers, so I want to find, of those customers, the ones that have rewards accounts. So I can go ahead and search that. I get a very specific set of customers. If I'm curious about how those customers came to be, I kind of want a more understanding of why those are the customers I'm looking for. I can expand out and see the whole context of the knowledge graph. So if I zoom in, see the electronics department, the purchases around that people have made, or the products, the purchases, and then the people. Here I see Giovanni McCool. I'm going to go ahead and isolate that person, dive in and pull up their record. More fun stuff to see here. We'll see Giovanni has these 29 orders associated with them that we know Giovanni made through their rewards account. So they went in a brick and mortar store, paid cash, but scanned a rewards account. So we're able to associate those orders with Giovanni. We can see this is this part of the semantic layer that infer that information so we can have a better understanding where that data came from. But to show you how all of this blends together with everything in the sphere of data management, in this case, the data catalog, you see here Giovanni McCool, data, customer, we've got metadata. Now we're going to go straight into the catalog. Where did we get customer data from? Now we're going to see all the sources that customer data came from, and they're going to be categorized. So we can see US customers here contain sensitive data. We can see one that's partially mapped. So there's some data in there that I can use. We can see our rewards account database. From any of these, I can go back up to the catalog and see where it came from. So I'm going to get Calibra to pop up here. Oh, excuse me, Elation. This one comes from Calibra. So this shows the case of we have multiple catalogs that come into play here that are bringing together data in this world. I can see what else is in these catalogs. Again, this is all point and click. Fully mapped sources, I'm not going to worry about those. I have unmapped sources. That's places data that might be useful to me could exist. New sources for the knowledge graph. I can go through that process, have a sprint, make those mapped sources. Which one of those might be relevant to the customer concept? Well, that's the reasoner. What it thinks of those sources could be related to the concept customer. This is using structural metadata and some simple heuristics. US point of sales or EU point of sales database and EU historical online purchases. Those look pretty relevant. So I've navigated from data to metadata, My metadata became data because metadata and data are really the same thing, all seamlessly blended together in this one knowledge graph. The last couple minutes left, and one pretty fun demo here. Actually, I'm not going to start there. We're going to go over to Designer real quick, just so you can see what the authoring environment looks like for creating these knowledge graphs for this last use case. It's a Star Wars knowledge graph. I created this for May the 4th this year and excited to reuse it. You can see the concepts that make up my semantic layer, everything you would expect from something Star Wars related. The blue nodes are nodes that are tied to external sources. So here in my authoring environment, I see a similar kind of experience that I saw on the Explorer side where I'm looking through my knowledge graph. If I look at one of these sources, you're going to see something that ought to look very familiar. NA, inconsistent NAs, NA used in place of null or blank. Sometimes units that don't make sense. This is kilometers in a speed column. Everything's a string. This is a total mess. So it's normal enterprise data in that respect. What do we do in these cases? Well, create a copy and then we go fix the data. Don't have to do that anymore. Don't have to be subject to the lax data principles of the Star Wars universe. So if I go over here, just jump into the data model, just so you can see it's the same thing. We see all the same concepts here in our knowledge graph. And if we go to the famous Star Destroyer, we can see here, pull up its record in the knowledge graph. We've got our strings, our plain data. We've got just strings here. This isn't super useful. I'm going to fix this, but I'm not going to change the data. I'm not going to do anything untoward to it. So sure I got the right graph, and then I'm going to pick this clean data model, and I'm going to turn on the reasoner. This enables the inference engine, and the inference engine is going to go through it and kind of fix this data for me. I created some rules that'll do the fixing, but it's applying them. So you can see already a different lay of the land. Things are categorized differently. If I go back into Star Destroyer, capacity, I left it in place. This is the raw string, not well denoted here, but this is cargo capacity in cubic meters. Same thing down here, length as a string, length in meters. We can see the original manufacturer. And now as a node, we've uplifted that string to a node. And now we can go in and there's more links. So we've created a richer graph just by that simple uplift mechanism. So we're kind of looking at this through a default lens. The Empire is quirky. They use a weird little system called Imperial. So they don't measure things in meters. They have a somewhat insane system of measurement. So let's switch over and just see what things look like from the Empire's point of view. You'll notice different ship classifications because they use different values for these and different unit of measurements. So automatically that kind of changes for me. I can go back in. Now cargo capacity, this is in cubic feet. Happen for me automatically. Now here, length in feet. But still some of the same uplift from strings to things that we see on the drive yards here. And so again, all that happens dynamically, and I know I'm running up against time. I want to show one last quick thing that I think is kind of fun. I want to look for everyone, all pilots who piloted something, and I want to find basically pilots who were in the original Star Wars. So they were participant in a unit in battle, and battle name contains Yavin. So again, run this, and I'll get, you see a lot of pilots here. So maybe I want to narrow that down, and the reasoner can be used for this as well. So I can, whoops, wrong thing. And I can say piloted, pilot, and I want them to be force sensitive. I don't need the results because there's not going to be many. There's going to be Luke and Vader. And I left the Empire's kind of lens on. You see Luke's classified as an enemy. It's the Empire's view of the world. So I can go ahead and I can switch over to the Rebel Alliance and I'll see a different picture. Luke's no longer an enemy. Luke's a friend. Darth Vader's the enemy. So another example of how we're able to slice and dice our world, interpret it in whatever way that makes sense for us in context, and see precisely what we need to see. So I appreciate everyone's time. Just to recap, the Enterprise Bermuda Triangle, storage, analytics, governance, bringing those together is a data integration problem. Knowledge graphs are all about that. Knowledge graphs solve a lot of the challenges we have with effectively using data and become the foundation of data management in the enterprise. If you want to learn more about knowledge graphs, in particular, if you want to dig into how I created this demo and see more of knowledge graphs in action, I've got a workshop tomorrow where we're able to get into this in a lot more depth. And if you're interested in learning more about Stardog specifically, stardog.com, you can try this out. The Star Wars demo is actually online, available to everyone, cloud.stardog.com. I appreciate everyone for coming today. I will stick around. I apologize I did not leave time for questions. Thank you.